everyone. My name is Peter Nilsson. I come from Xylem. I say it's great to be here. I used to work for Ericsson before, so it's good to be back. And I will talk about how we improved operational excellence through IoT connectivity. So I'm very digital. I have some notes here, so don't forget what I should say. So what is Xylem? Xylem is a global company, a leading water supplier to the water sector, and we do everything in the water side. We move, we treat, we monitor water to utilities, to industries and buildings. We also have a portfolio of metering devices and monitoring devices, so we can connect everything. We are a US company, headquartered in New York, listed on the New York Stock Exchange. So last year we had revenues about close to $5 billion. We're about 16,500 employees, and we're of 1,800 in Sweden. We have a large factory in Emmaboda, Småland, with about 1,300 people and heavy industry. And they're actually doing what we're talking about, customizing products for our customers. So they have a lot of, so it's a very modularized business. We are global, so we sell in more than 150 countries. And Xylem has lots of brands. So in Sweden, the most common brand is Flight or Flykt. So this is the cycle of water. And if you describe this, it's very important for us because we sell things here to the whole cycle. So normally you start in a lake, you take the water, you treat it, and then you transport it or move it, or we say pump it to the users within industries, building, agriculture, or similar things like that. When it's used, for example, when you flush a toilet or shower, it's pumped to a treatment plant. Moved back to the treatment plant. Then it's treated or not treated, and then it's moved back to a lake or a sea. So that's the whole cycle. Normally the same sea as we take the water from. So I work for the division concentrating on wastewater. And this is just to give you an introduction what we'll talk about later. So to the right, we have a normal standard pump station. So it's a small tank. It contains normally 2 pumps for redundancy, and we can take it out in operations and so. And they are connected in this network, a lot of pipes that ends up in the treatment plant. So a normal municipality, for example, they have between 30 and 400 pump stations. So if you take Stockholm, for example, they have about 200 pump stations and about 3,000 kilometers of pipes, wastewater pipes. Then, of course, you have lots of pump stations within buildings or shopping malls or airports and things like that. And they all connect to the same network and end up in the treatment plant. So this is also a picture of a typical pump station, a small municipal pump station. And this has been connected to a municipality SCADA system for many, many years, like 20 to 30 years. And but they're monitored and supervised and even remote controlled sometimes. So the most critical have been connected, which means that the ones that are the closest to the treatment plant, and also the ones that has some possibility to stop. So wastewater is kind of tricky because water is always the same, but wastewater contains solids to some extent, and sometimes it's too big and it stops the pumps. And when that stops, it can be an overflow, and that is hazardous waste. It's dangerous, and it also have to be reported to the authorities. So that's you definitely want to avoid. And they have been connected, but it's very costly to connect these pump stations. So you see this here, the box, the white box, that's the control cabinet. That is what we talk to. And that checks the status of the pumps. It counts the operation time for the pumps. It starts and stops them. It does some algorithms. It can increase the speed of the pump, so you actually clean the pipes. It can also run the pump backwards if there is some solid getting stuck into the pump. And normally this control cabinet is connected to a modem, and that modem is connected to a SCADA or similar system via PSTN, cellular, other radios, or fiber. Each of these control cabinets has, in average, about 60 data points. The modern has many, many hundreds. But you can read a lot of statistics from the operations here. Some is stored down to seconds, and some is just when they occur. So back to what I should talk about. This in 2015, I got the task to do something in the cloud. It was a bit vague, and we had some issues at the time with connecting these pump stations. We had a large installed base. We are the largest player within wastewater. We have about 2 million pumps in operation, but we don't know where they are. And we have a small part connected of those, but normally to the customer system, to some of our sales company system, but not visible for us. We had 3 internal SCADA systems that we sold, but none of them was actually possible to grow on a global scale. SCADA, the guy to the right, he's monitoring SCADA system. That's really complicated to use. You have to be an expert on that. You're looking on diagrams, comparing and what happened in that diagram the same time of the year last year. So it's really complicated. It's also really complicated to connect the control cabinets. And we had a limited number of experts. Our support worked, half of the cases was regarding connectivity, because the sales companies used to buy modems locally. They bought SIM cards from different operators, and then when you connected to our electric cabinets, it didn't work. And they can spend weeks on this. And then we also had most of the solutions was installed by the customers in the customers' premises, and there was also a lot of locally developed solutions by our sales companies. So we started trying to scope this project. And we had a lot of workshops. We talked about our internal experts. And after a while, we found out that no one really understood what we were talking about. We had the PowerPoints, but they didn't really understand. So we said that, okay, we have to build something that's real. So we have to show what it is. So we say, we build something really thin, but we build it end to end. So it's not, and it should be for real, not a demo or a mock-up or something like that. It should be able to use. And since we know that also, so we choose one of our electrical cabinets that we have sold for like 10 years. We have a large installed base, but most of them are not connected right now. And we also took a part of the data points, I mentioned, just the alarms from these control cabinets. So the idea was to take this to the sales companies and then later to the customers, and then get feedback and then improve the solution. So by doing that, we have a moving requirement specification. We had to work agile. So we started, this was the first project in Xylem, we started to work agile. And so this was kind of very much more business development than technology. So we said that we should sell a service only, not hardware. We used to sell SIM cards or modems and so, but we should sell this as a package, as a solution, instead of selling hardware. And we had a very good piece that we got from Telenor. That's the device here. It's a small modem or a cloud modem. It's like 10 times 10 times 3 centimeters or so. And that box, that's a full 2G and full 3G modem with a built-in SIM card and a global data subscription with roaming. So we can use that box and replace all of these local solutions. And that decreased complexity a lot. But we also needed help for this, so we didn't do this alone. We got help from a system architect. Then we started working agile. So we got help with the user stories. So we got started with that. We also used a company working with user experience and the UI. So they helped us to make the UI for this application. So it should also be simple to use. That was very important. We finally got, then in the end of 2015, of the autumn, we got the first developers in place, and that was in India. So that was a company decision that we should build up development shops in India. And we also had recruited a couple of people that had made this journey for other industries. So I think then we had a small team to start working with this. So in May 2016, we had our first application on the production available. So it took about 9 months to make this ready. So if you look at the same picture as we shown earlier, we had the pump station or electrical cabinet in that side. We had the Telenor device. That was very important. And that was always bundled with the Telenor cloud. So you could not use it for other operators, which simplified a lot. And then we used part of the platform from Telenor, and also from our internal, we're building a framework that we call xCloud. And then we had an application that we call Xylem monitoring. And what it gives is for the customer is a kind of peace of mind that my equipment is working. I don't have to worry. And this it's a bit complex to build a total solution, but that is only part of the chain, because this is we build it once. But over time, it's much more complex when you actually operate a solution like this. We have ongoing platform changes in this. And for our customers, you can't miss an alarm, because if you miss an alarm, you're out. So that's extremely important. Because this is critical infrastructure, and you can't miss something here. So I think that has been a challenge also, that we have made some learnings over time. For example, in the device, we hard-coded what it should read from our pump stations, and then we realized that when we tested that this was not so clever, because that hard coding was made externally and took some time to make changes. And we found some issues on our existing products that we found first when we connected the whole chain. So that was an experience. Just to give you some background, we are working now agile. We're working in 3-week sprints. We have continuous release of this function after every sprint. We started with 2-week sprints, but then we were not able to do the full testing. Then we have, after release, we have it going on a test server for 1 week. Then we go to production. But I think the lifetime management of this is the complexity. So right now we have 2 ongoing platform changes that we need to manage at the same time we have an operation. So that takes a lot more resources than you think. So next step was then go out and test it with customers. So this is the first installation we did in the summer of 2016. It is in the center of Trondheim in Norway. And here we have a little box, the control cabinet. It's located in a small street onto a main street, and there is this red lamp on top of the control cabinet. So when there's an alarm, no one notices in the center of the city. So it has to be connected. So that's where we started. So when we did this development, we worked very closely with our sales companies and our expert users and the people that were interested in new things. I think that was really, really important. They also had to be friendly users. So there's a lot of, since we have this local solution, that can be that some already had a solution that they think their cabinet needs. So you have to find maybe the non-experts that actually can be helped of this. So that was a success for us, because we could address the service people who had no installation or a SCADA experience. And by doing this, we also found a new market segment that didn't exist. So there were lots of more pump stations that was able to connect that we didn't thought they were interested to connect. So I think that was a very positive thing from this. And what we found out was that our internal savings were much bigger than the revenue. But of course, from management side, they want revenue because that's what they measure on. But we have to show them that internal savings are that big. So I think that is what we're talking about later. We also, since we were selling this as a service, we are a cast iron company. We do our pumps in cast iron, and our IT system are supporting that fully, but they're not supporting so much selling a software or selling a software as a service or a product as a service. So we have to bypass that because we should not invest in a new IT system right now. So we found that we had service agreement where we actually maintaining our pumps. And by extend that a little bit, we can include the connectivity, and then we have also the billing already in place. So, and by doing this, we got a very good confirmation. We had some findings. When we launched this, we actually went to the workshops. We trained the service guys, and then they had to go out to customer and install it. And we looked at how they were working, what kind of issues they had, and we found some interesting things that we haven't thought of when we did development. So this is another case, also in Norway. It's a kindergarten in outside Kristiansand. It's a typical case. Building was on a slope, and since they had lots of the pumps that clogged because they're using wet wipes and diapers that ended up in the pumps, and then the pumps clogged, and then we had an overflow, and there was a discharge in the river that was beneath. And so normally there's a 1 hour drive to that customer. There have to be two servicemen of safety reasons. And normally they went there, they saw what the problem was, went back to the workshop to pick up spares and went back again. And so they had to bill like 8 hours just for travel time, which was unnecessary. So we installed the device made by them. And the device cost less than one visit, so the payback was immediate, more or less, you could say. And so we also had more problems with this pump station, but then we also saw that now they have a problem. They can call the janitor, try him to restart the pump. Sometimes it worked. When it didn't work, they could say, it's a kindergarten. They go home at 5, then there's no business. So they could actually wait until the morning instead of going on emergency. So I think in this workshop they have just 3 guys, so they have to be very careful what they spend the time on. So I think there are lots of savings from internally. The customer didn't even notice now when they have a problem, so we just solve it. He gets the bill though, but the bill is much smaller than before. And of course we save a lot for environment, both from the discharge of wastewater and also from the much less driving. This is just to give an overview. We started from the left, and we are somewhere in the middle. We have started with some managed services, but I think now what's next for us is that we have to connect to the legacy out there, because our customers, they have SCADA systems, and they will not change that because we have a new IoT solution. So we have to make a way to connect to that, and that market is very fragmented, and this SCADA system are custom-made more or less for our customers. We have now the infrastructure, so we can read up all the data from our products. So we're starting with the first analytics project, and we need to also to able to sell more, because we can control everything else, but then selling and the customers buying. I think that's the hardest part there, and we have to transform, make it simpler for our salespeople to actually sell a solution like this. I think the operations part is very important, and I think what Martin mentioned, there is a lot of things. We have been lucky to been able to doing this for 3 years. First year we have had good funding. We were able to get consultants from outside. The second year was a bit slower. We had to work with half the resource needed or so, but we haven't had any real requirements on revenue. There was, of course, visions, but no one actually stopped the project, which has been lucky. So I think now we have a very good foundation to continue to roll this out. So thank you for listening.